Potential energy approach. By using this approach, we may find out the element stiffness matrix force vectors of any domain. So, potential energy. We know that potential energy equation phi of P is equal to U plus W. Well known this equation. Here we can say that the potential energy is defined as the sum of the internal strain energy and the potential energy of external forces. So here the U represents the internal strain energy of the system and W represents the potential energy of external forces. So internal strain energy, internal strain energy. Internal strain energy. U is equal to half of volumetric integral stress in x direction, strain in x direction into dV. This is the equation 2, represents the internal strain energy of the system. So external force, external force. So in the external force, W is equal to, it is sum of the three forces, F, V, U, dV plus integral V, T, F, U, ds plus I varies from 1 to n, P of I, U of I. This is equation 3. Here, in this equation where Fb represents the body force, or simply you can say that force per unit volume, and Tf means traction force, or we can say that surface force. This is force per unit area. And P represents the point load, or we can say that concentrated load. So all the forces are considered to act in the local x direction in this case. So the total potential energy of bar subjected to loads given by the bar. Here we consider the bar finite elements. The bar finite elements we consider here. So in this potential energy equation is equal to this discretizer. Because of that reason, it is varies from 1 to n number of elements. So half of volumetric integral stress into strains dV minus varies from 1 to n of dB U into dV minus is equal to 1 to n Tf into U dV minus into 1 to n P of I U of I. This is equation 4. So this is the bar has been discretized into finite elements. Once we know this total governing the equation of motion, Then we can separately find out the how to derive the element stiffness matrix of a one-dimensional element by using strain energy and force vectors for this bar element. In the next lectures, we learn how to find out this element stiffness matrix and force vectors.